Okay, so if you don't have this out yet, make sure you go ahead and get this out. Hit pause. Okay, so now parametric equations. What do we got? Well, basically, parametric equations are in a way that x and y or any other variable are not dependent upon each other but a different parameter, hence the name. Examples of this use are things like a Cricut cutter, that, or any kind of a table cutter where we'll cut a design. The horizontal and vertical on the sheet is defined based on time, because we know how fast the cutter moves around the table, around the design. And then usually for those they have another one, Z, the vertical, the up and down. So when the cutter's down, it's a 1. When the cutter's up, it might be a 0 or something of that nature. So they cut it that way or vice versa. And or if it's in relief, there'll be different levels, different layers of those. So that's basically the use of parametric equations as opposed to other things. Okay, so first of all, when we take care of this, and when we do what's the parametric equations, find the coordinates of the point. When what happens? When t is 2. So what is x when t equals 2? So 2 cubed plus 1. What's y? When t is 2. So that's 16. 9 minus 16, negative 7. So when t is 2, with this set of parametric equations, we would have the ordered pair at 9, negative 7. Okay, so let's look further down. Let's look at number 3. Let's plot the graph only from negative 2 to 3 for t. Okay, well, one way to do this is to go ahead and just use a table of values. T, what's x, what's y, and then if you want, many times we'll add an optional writing x and y as an ordered pair. I don't think we'll do that because we can see what the x and y happen to be. Well, before we get into that, let's take a look at what we're looking at here. So here we've got the parametric equations, 2t for x, t plus 3 for the y. And here's the ordered pair. So when t is negative 2, we get that ordered pair. And then negative 1, t is negative 1, 0, 2, sorry, t is 1, now t is 2, and t is 3. So we get these sets of ordered pairs. Now, we know this is going to be a curve. We just pick nice integer values of t. We've got all these other ones in between that we don't list out. In other words, we get this line connected through them. We'll come back to getting that line, that equation in a little bit. So going back to here, so we just list nice values for t. Negative 2, negative 1, 0, 1, 2, and 3. Now, and then plug it in. So x is 2t, so 2 times negative 2, negative 2 times negative 1 for t, times 0, 2 times 1, 2 times 2, 2 times 3, again, just using that equation. And y is t plus 3, so negative 2 plus 3, negative 1 plus 3, 0 plus 3, 1 plus 3, 2 plus 3, 3 plus 3. And there's our ordered pairs we saw earlier. So we go to the graph and just graph those ordered pairs. Negative 4, 1, negative 2, 2, 0, 3, 2, 4, 4, 5, and 6, 6. And because of this restriction up here, we only connect them from start to finish. That's it. We don't connect them anymore. Now, getting back to the equation, we've got a couple of different ways to think about how we can get that. We can, of course, draw it. Now go get the equation, make this up, or what we call is remove the parameter. So instead of having y equals to t plus 3, we need to change the t using x. So we get this equation. So what is t equal to? And substitute in there. So now instead of t, we're going to have 1/2 x plus 3. And we're done. No other simplifying, no other solving. That's how I got this equation here. Now, what about this here? If we wanted to restrict it, what was x? Where did x go from? The interval of x. From -4 at first to 6 at the last. Okay, so let's look at one more example. You see a whole bunch of graphs. What you can do is eliminate the parameter. Again, let's get this as y in terms of x. We really have a system of equations with 3 variables, but only 2 equations, which you may have thought, wait a minute, we can't do that. Well, we can't solve exact values, but we can solve for other things. We can find an equation from that. Well, again, does it matter which one you solve for, x or y, and substitute? Nope. Could you use elimination? Yeah, that gets ugly though, real quickly. So think about substitution. Most of the time, we'd like to solve for x, or solve in the x equation. So x divided by 3 is t, so now substitute that into t and the y. So instead of t, x over 3. Can you do anything with that? Nope. And that's why you see it written as 1/3 x plus 3. Now, restrictions. Well, what about x? If t goes from -2 to 3, what does x go from? So when t is -2, x is when x is 3, t is 3, x is, so that's the line, but only that portion of the line. Okay? Now, we do have some other examples and stuff like that in physics for parametric equation, and I'll just take a look at something like that right quick here. So we'll go to that. Sorry about showing this. Okay, so if we just look at, if I have, okay, I'm gonna have something, a projectile launched at 49 meters per second from the ground. What about its height? Well, its height goes, whoop, don't want to show that one yet. So its height goes straight up and down. Now this is what in physics we talk about projectile motion. It's up and then goes back down. That height is not related to the horizontal distance if it's moving at 3.5 meters per second horizontally. So this is something launched at an angle, and so the height just, the horizontal distance just goes that way till we get out to 10 for the first 10 seconds. So that's the height. Now when we look at both of them, the horizontal and vertical at the same time, Watch what happens to the 2 points. They both go up. There we go. There we go. One's going up. The height's going up, and that's this one here, where the horizontal keeps moving. Up, 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 and down, down. And then notice the projectile, the thing's going down, but yet it's still moving to the right until it hits back to ground. We're used to seeing this. Now let's put the 2 points as one. Notice this point here. Actually, this is the time against the height. Let's look as the height goes up, as time moves, it's going up, 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 and then starts coming back down, but notice it's only 10 seconds long. Instead of doing that, let's put horizontal distance against vertical distance. Watch what happens with the ordered pairs. Don't need that other one. There's our familiar parabola for x comma y, but both of those, the y isn't depending upon the x. The height isn't dependent upon how far it moves horizontally. It's all dependent upon the height. That's the parameter. That's the parametric equation we talked about. And now if we would go ahead and, instead of the ordered pairs, there's our familiar parabola. Let's look at what happens to the actual projectile as it's floating through the air. Boom. So that's a use of a different use of parametric equations. Okay? So again, going back to here, this is what we're familiar with. This is what we're focusing in on. We'll use parametric equations in many different things later. Not here, but later as you do things. Okay? Because again, for all those different variety of options. All right.